Welcome to the Building iPhone Apps with JavaScript using Titanium screencast. We're going to explain how to build a native iPhone app using Appcelerator's Titanium Mobile SDK, which allows you to write JavaScript to create native apps for both iOS and Android devices. We're going to build a screencasts.org iPhone app, but if you wanted to get it running on Android devices, it could be done with a bit of code branching. Appcelerator's Titanium provides a bridge between JavaScript and native Objective-C for iPhone and native Java for Android. So building apps with Titanium has the benefit of using the familiar JavaScript language while still getting the native app experience for both iOS and Android platforms. Native applications often feel more responsive than some other HTML and JavaScript wrapper frameworks that are out there. This is where Titanium shines. We found Titanium to be really fast and easy for relatively straightforward apps, like the Screencasts app we're going to build today. It will use table views to display data and play videos. But there are other app solutions we prefer for other kinds of mobile app projects, which we'll cover in future episodes. Appcelerator's Titanium is a fairly young platform, and its documentation reflects that. Just be aware that you may have to do a bit of digging to find what you need. Their documentation is available at developer.appcelerator.com. To get started, download Titanium at Appcelerator.com. You'll need to create a free Appcelerator account, so complete the sign-in form when Titanium launches. Titanium will save your login info for when you launch the app in the future. You'll also need to install the iOS SDK from developer.apple.com, and you can also download and install the Android SDK by visiting developer.android.com. Install your SDKs as directed and then launch Titanium. Titanium should recognize your iOS SDK, and you may have to point Titanium to your Android SDK. We had to jump through a few hoops to get Titanium to recognize the Android SDK, so be sure to follow the latest instructions at Appcelerator.com. Let's click New Project in Titanium's top menu, then select Mobile from the Project Type pull-down menu. Let's name the project Screencasts. Next, we need to create an app ID. App IDs are like URLs in reverse. We need to enter com.companyname, in our case Secret Monkey Science, .appname, which will be Screencasts. Next, we set a directory for our project on our local machine. You can also optionally set your URL. Next, set the Titanium SDK version, which you'll usually want to be the latest version. You'll see which mobile platforms are correctly installed on the next line, iPhone and/or Android. Next, click Create Project, and you'll see Titanium add Screencasts to our Projects menu in the left column. We're also given a panel of some basic settings for our app. Let's click Test and Package in the top menu bar, then under Run Emulator, we'll see a blank console screen with Launch and Stop buttons below it. You'll also see an iPhone or Android toggle above the console screen for testing our app in each simulator. We'll test on iPhone, so let's click Launch, and we'll see Titanium display a few build messages in the console, then the iPhone simulator will launch. You'll see that Titanium has provided a basic app skeleton with 2 tabs, and when you click on each, the window changes from I am Window 1 to I am Window 2. The navigation bar title also changes. Okay, let's click Stop in Titanium, and let's start building our app. To follow along with this screencast, you'll need to download several assets including images and support functions. They're available to download in a zip file on screencasts.org. Be sure to download and extract these into the Resources folder. Using your text editor of choice, open the folder containing your project files that you specified when creating your app. We'll be working exclusively inside this Resources folder. The app.js file is the root file where you'll want to start writing the JavaScript necessary to build your app. Inside, you'll see the JavaScript that Titanium used to build the basic app skeleton we saw in the simulator. We'll clear out the placeholder code and start from scratch. First, we'll set the background color for the whole app and create the tab group, which will hold all of our tabs. Our app will use 2 tabs, one for our latest episodes, the other for our topics. When writing out many of Titanium's functions or constants, you can substitute the shorter TI for the full word Titanium. You'll see us use a mixture of both in this screencast. Next, we need to create a window which will contain our first tab. We'll set the title to be blank, which would have appeared in the navigation bar, and instead set a custom bar image, iPhone-bar.png. If we don't put in an empty string as the title for this window, the tab's title that we're about to create would be used by default. We'll also set a custom background image to show behind our table view. Our first tab is going to show Latest Window, which will contain a table view that lists our latest screencasts. We'll create a tab called Latest Tab, and we'll set the icon to our clock icon, the title to Latest, and we'll set the window to Latest Window. So, when this tab is clicked, it will show Latest Window. By the way, we're using icons created by glyphish.com, which are a must-have for iPhone developers. Now, our second tab is going to be wired up a bit differently. It's going to show a table view with a list of topics, and when you click on a topic, it will drill down to show all of the screencasts that are tagged with that topic. So to have this drill down behavior, we'll need to create a window that will contain a navigation group that will then hold all of the sub-windows. First, let's create the window that will contain our navigation group, which will be shown when our Topics tab is tapped. We need to hide the Window's navigation bar since it will be replaced by our navigation group. We're going to add a nice background so that when we pull on the end of our table views, it will be revealed. We'll now create our first sub-window, which will contain the Topics table view. Again, we're using a custom background image for the bar, so we need to pass in an empty string for the title. Next, we'll create the navigation group and push our Topics window onto the navigation stack. Then, we add our nav to the navigation window. Next, we'll create our Topics tab and set Navigation Window as its window, since that's the parent window of our navigation stack. We'll give it the title Topics and a Tags icon. Then, we add our two tabs to the tab group in the order we want them displayed, and then call Open on our tab group to make it visible. We're going to build the functionality of the Topics tab first. Let's create a table view to hold our topics. We'll pass in an empty array for the table view's data option. Each entry in the table view's data array corresponds to a row in the table. We need to set its background color to transparent to reveal the nice background image we have on our navigation window. Background color usually accepts hex colors, but has the option of being set to transparent as we're doing here. Next, we'll add the Topics table to Topics window. If you launch the app in the iOS simulator from within Titanium, you'll now see that our tabs are in place and our custom navigation bars with images are also in place. The background images are there, but we need to set up the table views and their data. To populate our Topics table, we're going to read in data from a JSON feed on screencasts.org. We'll need to create an instance of Titanium's HTTP client object. If you look at the documentation for this object, you'll see that it mostly implements the XML HTTP request specification. If you've been writing AJAX code and writing callbacks for XHR requests, you're already familiar with Titanium's HTTP client. We'll be using XHR in the names of these instance variables since HTTP client is interchangeable with XML HTTP request. First up, let's create an XHR object that deals with the topics. We'll call it XHR Topics. Next, we'll need to write an anonymous function for onload. Inside this function, we'll add all of the code we want to be executed when data is returned from the server. If we take a quick look at our Topics JSON feed at screencasts.org/topics.json, we'll see that an array of topics is returned. So we'll parse the JSON into a topics variable. Next, we'll set up a data array which we'll use for the table view. Let's make it an empty array so that when we cycle through our topics, we can push rows on. Now we'll create that loop which will iterate through our topics and set the contents for each table view row. Let's create a topic variable for convenience in the loop. Screencasts.org has a custom color for most topics, so we're going to save that to a variable with an inline conditional or ternary operator. If the topic doesn't have a color, we'll set it to a blue hex value. We're going to use this color to set the row's background color gradient. Next, we're going to use a function we wrote to get a slightly lighter shade of the topic color, which we'll use in our background gradient. The way this function works isn't particularly important, but we'll need to add the ti.include line for this file at the top of our app.js file. We then create our second color variable, lighter custom color, by calling this function, passing in our custom color. This file was included in the download zip file for this screencast on screencasts.org. As a quick side note, ti.include is primarily how you'd organize your apps once they start growing in complexity. We're trying to keep this demo simple and mostly all in one file, but moving your supporting code into supporting files is usually a good idea. Next, inside this loop, we're going to create the actual table row, passing in several parameters. HasChild True adds the indicator arrow to the right side of the row, indicating to the user that tapping on this row goes somewhere. Height sets the row height. Topic being set to topic is our way of adding our entire topic object from the JSON into the row object so we can use it later. This is a valuable point to remember. You can add your own instance variables to Titanium objects like windows and views, just like you would with any other JavaScript object. We're just creating a very basic table row, so we just need to set the title to topic.name and style it with font size and color. Then, we'll set the selected background color for the row, which is the color the row's background will turn when tapped. And finally, we can set the background gradient going from our custom color to lighter custom color vertically. Then, we'll push our row onto the data array, then cycle back through the loop for each topic object in our topics array. Once the loop is finished, we can set data to our data array for the topics table. Then, after the onload function, we can tell our HTTP client to open a GET request, passing in our topics JSON URL. Then we call send to trigger the request. Let's launch the app again in Titanium and click on the Topics tab, and as you can see, the table view is there with all of our custom styling. Great! In a minute, we're going to create a table view that will load when a topic row is pressed. This new table will show all of the screencasts tagged with that topic. The cells in this new table view will actually look just like the cells in the latest table view, so we're going to create a function that takes episodes data from the JSON and converts it into a data array suitable for use in a table view. We'll call this function episodes to data and pass in the raw array of episodes. A lot of this code should look familiar from the topics table. We're looping through the episodes array, creating table view rows, adding elements to them, then pushing the row onto our data array at the end of each loop. We're adding a variable called video blip ID to each row, which is a string blip TV assigns to each of our videos. Instead of just using the default title attribute when creating our table view row, we're going to create a more customized row. We're going to add a thumbnail image to the left of the row and add a label to the right. We create an image using the titanium.ui.createImageView command. We pass in the image URL to the image parameter and set the left parameter to -155, which pushes the image over 155 pixels to the left of center. Next, we add the image to the row. Now let's create our episode title that will appear on the right. So our text is our episode.title, color a gray color, and then we have some font styling and positioning. Next, we add the episode title label to our row and push the row onto our data array. When the loop is finished running, we then return our data array. Now let's move on to creating our single topic table. We'll create two variables that will populate later, which will save our topic title and topic color. Next, the create table view command for our single topic table will look similar to when we created the table view for the available topics. Then, we'll create another HTTP client object, single topic XHR, and implement an onload callback for when we get the single topic's list of episodes as a JSON feed. In the onload function, we'll parse the JSON we get back into an episodes variable, which is an array. Then, we'll create our data array for our single topic table by calling episodes to data, passing in our episodes array. Next, we call a function we created called addEmptyRows, which just helps keep our app looking nice. Since our table view background is set to transparent, we want to make sure that we have at least a full screen of table view rows. This means we want to have at least 5 rows in each table, and this function adds those extra rows as necessary. Let's include this from a supporting file. We'll do this by adding a ti.include at the top of our app.js file. This addEmptyRows.js was also included in the download accompanying this screencast. We then set data for our single topic table to our data array and create the single topic window which will hold our single topic table view. We'll set the title for this window to our single topic title variable. Finally, we'll set the bar color to our single topic color variable, which makes our navigation bar the screencast topic's color. Next, we add the single topic table to our single topic window. Then we set the back button title to topics, which will show in the navigation bar so users can go back to the topics table. Finally, we'll push the single topic window onto our navigation stack with the open method. Next, we'll set up the click event listener for our topics table with an anonymous function containing the code we want executed on click, which means when a row is tapped. The function passes in an event, named E in our case. In the function, we'll set the single topic title and single topic color variables, then open and send the request via the HTTP client we just set up with a custom JSON URL built for the specific topic. We'll build the URL with the variable slug on our topic of the selected row. It reads like this, e.row.topic.slug. Remember earlier, we saved each topic in each row. We can now access it again by calling .topic on each row. The slug is just a string we use on our site to build URLs. We can use ti.api.log to help debug our app. When this click event listener is fired, we can write a log statement to make sure our URL is being built correctly. ti.api.log will write out information to the Titanium console when you pass in a string or an object. So, if we launch our app again in Titanium, we'll see that when we tap on a row in our topics table, it correctly opens our new single topic table for each topic. Tapping the Topics button in the navigation bar navigates us back to the Topics table, and we see that all of the topics are functioning correctly with our custom nav bar names and colors, topic images, and titles. Also in the console, you can see the URL being built correctly. Now, we're going to create a table view for our latest tab. Like before, we'll create a table with an empty array and give it a transparent background, so when we scroll past the end of our table view, the background underneath will show through. Then, we'll create a new HTTP client instance called latestXHR. We'll implement its onload function, which will parse the JSON into a latest episodes array. We'll then build the data array for our latest table by again calling episodes to data, passing in the latest episodes array. We'll then set data for the latest table to our data array. Next, we'll add our latest table to the latest window, then tell our HTTP client to open a GET request, passing in our latest episodes JSON URL. Then, we'll call send to trigger the request. If we launch our app in Titanium, we'll see that this table view is working correctly on the first tab. The final step for this app is to play the videos. We're going to add a click event listener so that whenever an episode row is tapped, that screencast video will be launched in the player. In order to get the actual video URL, we need to make another HTTP client instance and send a request to Blip TV, which is where we host our videos. We'll send a GET request to a URL provided by the Blip TV API. In the API URL, we'll include the episode's video blip ID, which we've saved as a variable in each row. This will return a JSON feed with a lot of data about our video, but we're just going to pick 2 URLs out of it. We're going to use the SD video URL for iPhone 3GS and below, and then the HD video URL for iPhone 4s. Since we're going to be using the same behavior when latest episodes rows and regular episode rows are tapped, we're going to create a named function that we can reuse for both click event listeners. Let's call it load remote movie. In this function, we're first going to check to see if the row's hasChild variable is set to true. This is one of the variables we set on all rows that actually contain a screencast. It would only be absent if the row tapped was one of the extra empty rows we added to fill some of our single topic table views. Then, we open a Load Video XHR HTTP client that we're going to implement in just a minute. We'll open a GET request, passing in the BlipTV API URL that will give us our episode data. Then, we send the request. After we've defined the function, we're going to add it to click event listeners for both the single topic table and latest table. The BlipTV API URL requires a callback, so we need to set up a callback function with the name we're passing into the GET request. In our case, we're calling it getVideoData. The JSON data that BlipTV returns is an array with one object, so we're going to return JSON data at index 0. So let's create the HTTP client to talk to BlipTV. We'll have to include this above our load remote movie function, since that function calls the HTTP client we're now creating. BlipTV doesn't offer a plain old JSON feed in their API. It does, however, provide JSONP, which is essentially JavaScript code. Therefore, the response text we receive needs to be evaluated with eval as opposed to parsed, as we did with our screencasts JSON feeds. Next, we're going to add some code that will use the HD URL for iPhone 4s and the simulator, and then use the SD URL for iPhone models 3GS and older. To do this, we use titanium.platform.model, which we compare against the strings iPhone 4 and simulator. Next, we create our video player with titanium.media.createVideoPlayer, assign its URL, and set full screen to true. Next, we're going to create a window to hold the video player called Video Window. We'll hide the nav bar and set a custom variable isClosed to false. We'll come back to this isClosed variable in a minute. We'll also set orientation modes to an array that includes all 4 possible rotation constants, since we want people to be able to rotate the video window as desired. The video player has several default events which you can assign listeners to. We're going to make use of the full screen event to simplify the way users exit a video. When a video launches, it will trigger this full screen event since we're setting full screen to true. So we also want to check if we're entering the player, which is another default event. If we're just entering, we don't want to close the video window. So, if a user has finished watching the video and clicks the Done button in the top left corner, it will trigger the full screen event. e.entering will be false, and isClosed is false as we set a minute ago, so the code inside this if statement will run. First, we reset the orientation modes for our video window to only allow portrait mode. We're doing this to fix some odd behavior we were seeing when leaving this window, so it's kind of a workaround. Next, we stop the video player and close the video window. Then, we set our isClosed variable to true so we don't accidentally run through this loop again if the full screen event is triggered again for any reason. Then, we release the video player to free up resources on the mobile device. Finally, outside of the full screen event listener, but still in our onLoad function, we'll run through the final steps to actually open the video. We'll open our video window as a modal window by setting modal to true. We're also setting animated to false to stop the modal window from animating up from the bottom of the screen. If you're unfamiliar with the term modal window, it just means that we're opening it up in front of our other windows. This type of window is intended for things that temporarily interrupt the flow of the application, then let the user do or experience something, and finally return to the app's normal flow when closed. Then we add the video player to our video window, show it, and finally play it. If we launch the app again in Titanium, we'll see that our videos are loading correctly when a row is tapped. And if we rotate the simulator by pressing Command plus the left or right arrow, we see that the video window rotates correctly. And finally, if we click the Done button, our video window removes itself properly. And that's it! We're going to submit this app to the App Store under the name Screencasts, so be sure to watch for it there. Thanks for watching! Subscribe to our RSS feed, follow us on Twitter, and please leave any comments, questions, or suggestions for new screencasts in the comments below. If you like our videos and think your friends, followers, or colleagues would benefit from seeing them, please feel free to share via any of the links below the video. We really appreciate your support. See you next time!